My name is Mr. Emil Villanueva, and welcome to General Physics 1.
Today's topic is about motion graphs, where we pair displacement, velocity, and acceleration to the independent variable, which is time, and describe what happens. We have the displacement versus time graph, wherein the displacement is the y-axis and the time will be the x-axis. Since the ball moves at a constant rate, at each time interval, we observe that we have similar displacements. So let's plot this. So our graph describes the ball's displacement constantly increasing, which is observed by this steady upward slope. In our lesson for today, graphs will imply more quantities than those indicated in our x and y axis. The slope not only represents the displacement, but will also represent the rise and run. If you replace the rise with displacement and run with time, what is displacement over time? It's velocity. Now let's solve for velocity after 2 seconds. The rise is 2 meters and the run is 2 seconds, which equals 1 meter. Even if we do this again at different points of the slope, since our slope is in a straight line, this will only indicate that the velocity will be constant. For this problem, it's constant at 1 meter per second. Solving the slope is easy. So now, let's analyze the displacement versus time graph. We are shown different points in the displacement versus time graph. Each point represents the motion of an object. Let's describe this graph. Let's look at the first interval, 0 seconds to 1 second. Can you guess the displacement and velocity? The displacement is headed towards the positive direction, and after 1 second, it travels 2 meters. But since we see a straight line, the velocity is constant at 2 meters per second. Now to the next. Try and guess the displacement and velocity. The displacement is constant, the object is not moving, and we're stuck at 2 meters. And we know the velocity is 0, since looking at the slope, we see a horizontal line. This gives us no rise, so the slope and velocity is 0. Next, what if we have this? Can you describe the displacement and velocity? The displacement is headed downward, and we're going back to where we came from. We know this since we went from positive 2 towards 0, which is the starting point. For the velocity, it's constant, but at a negative rate. So this means our velocity will be negative 2 meters per second. Next, what happened to the object's displacement and velocity? The displacement headed downward, so that means we went from 0 to the opposite direction, which is negative. The velocity, on the other hand, is still constant at negative 2 meters per second, since we still see a straight line downward. Finally, the displacement seems to be constant at negative 4 meters, which also means that we stop moving during this time interval. And if we stop moving during this time interval, the velocity would be 0. Now let's change the slope of our line to something curved. What now happens to our velocity? We can see that for each point we measure the velocity differently. First we have 0.33 meters per second. Then we have 1 meters per second. And finally, we have 2.67 meters per second. If you ever see a curved line, that only indicates a non-uniform change in that quantity. So our slope represents velocity in the displacement versus time graph. So this upward curve indicates a positive non-uniform change in velocity. As you can see, the velocity is not always constant.
I hope you learned something. See you in the next video. Goodbye!